can I see 13 by any chance? Okay, so 13 on last night's homework. Oh yeah, this was, okay, this is an nth term test for divergence. Okay, what you have to do is you have to take the limit of this as n goes to infinity, or this is k, right? Oh, why do I have a k? Oh no, the k is just a constant. So as n goes to infinity of 1 plus k over n to the n. You do this, and what you'll do is you'll get an answer. Do you understand? If this is nth term test for divergence, if this is a number, right, then this thing diverges. Everybody good with that? So I'm going to try to get this to be a number. Do you remember if you have n raised to the n, you set this equal to y? Okay, and then what you do is you take the log of both sides. You take the log of both sides. Okay, but remember the limit of the log of a limit is a limit of a log. So then what I'll do is I'll say the limit as n goes to infinity of ln of 1 plus k over n raised to the n is equal to ln of y. And actually, let me erase all this. Do you remember that? Do you agree that if I find this limit, if I find y, then I find this limit, right? If I find y, I find this limit. So I took the log of both sides. Now I'm going to take the limit of that, or no, then I switch the log and the limit. And then what that allows me to do is actually, because of log properties, it allows me to move my n right there, okay? And now I'm just going to work the left side. If I plug in infinity, I'll get infinity times ln of 1 plus 0, right? If I plug in infinity here, this is a constant, right? So that's going to go to 0. So this is infinity times 0. Infinity times 0 is indeterminate. But do you remember from long ago, we said anytime you get 0 times infinity or infinity times 0, what can you do? L'Hopital's. But you can't do L'Hopital's until you force this into a fraction. L'Hopital's only works on a fraction. So then what I do is I put this in the numerator. Oh, sorry, this n should disappear. Put this in the numerator. Put this in the denominator, but I have to use real algebra. So this n has to turn to 1 over n, okay, because I can't change the expression, all right? If I plug in infinity now, I'll get 0 over 0. Okay, so guys, if you do this on the AP test, somewhere on your paper, put 0 over 0. They're looking for that for partial credit. Actually, to get full credit, you have to have this somewhere. Okay, 0 over 0. And you cannot have the equal sign in front of it. So please do not ever say something's equal to 0 over 0. All right, then what I do is I say, hey, if you're 0 over 0, you can do L'Hopital's. You can invoke L'Hopital's, which means I take the derivative of this. Okay, it's u prime over u over the derivative of this. This is really n to the negative 1. Okay, so the derivative of n to negative 1 is negative n to the negative 2. And L'Hopital's is still a limit. I forgot that. So that's what this L stands for, still a limit. This is u prime over u. This is my u. Okay, so the derivative of this, okay, rewrite this. This is 1 plus k times n to the negative 1. So this is equal to the limit as n goes to infinity. The u prime is taking the derivative of this. The derivative of 1 is just 0. The derivative of k n to negative 1 is negative k n to negative 2 over u. This is my u. U is this whole thing. So it's 1 plus k over n all over negative n to negative 2. Okay, so all I did was take the derivative of the top by itself, take the derivative of the bottom by itself. The n minus 2's actually cancel out. The negative signs actually also cancel out. So what I get is a limit as n goes to infinity of k over 1 plus k to the n. As n gets bigger and bigger and bigger and bigger, what happens to this fraction down here? It goes to 0. So this just goes to k. K over 1, which is k. Okay? And so, guys, remember, though, k is equal to ln of y. And remember, if I find y, I find my limit. So how do I find y here? You e both sides. Okay? And eventually, if you do enough of these problems, you see that it's always e raised to the k. I don't know. Whatever this number is, it's actually e raised to the k. And if this were a negative k, like if it were 1 minus, like if it were 1 minus 2 over n, like this, your answer would actually be equal to e raised to negative 2, negative 2. Okay, it's always e raised to whatever this k is. Let's see. And so, I haven't even finished the problem. So since this is equal to e raised to the k, is this a number? This is not equal to 0. So therefore, this series diverges by nth term test for divergence. Okay, that was fun. I want to think about the difference between a sequence converging and a series converging. If you guys pull out your homework, your last two questions, number 15 and 16, if you had trouble with that on your homework, it's because of this concept here that you're not quite understanding. So I want to try to nail that in the head today. What's the difference between a sequence converging and a series converging? All right, so we're going to take the same a sub n, and we're going to see if the sequence converges, and we're going to take it and see if the series converges. If you're asked if a sequence converges, just like if this a sub n converges, really all they're asking you to do is take the limit of it. Okay, this was your worksheet 1. When we came back on Monday, what you did whole worksheet work is, does the sequence converge? Okay, and all that means is take the limit. So what it means, if you set up a podium, so if I set up a podium, I'd have 2, let's plug in, I'm going to start with n equals 1. And again, starting with n equals 1 is arbitrary. I could start with n equals 2. I don't have to start with n equals 1. Actually, let me start with n equals 2. You'll see you really get the same answer. So I'm going to plug in 2. Then I'm going to plug in 3. Then I'm going to plug in 4. Then I'm going to plug in 5. And basically all the way till n goes to infinity. So dot, dot, dot. And this will be n goes to infinity. And the question is, what is in this blank? The question is, what is in this blank when n goes to infinity? And these are sequences, so they're going to be commas in between. All right. Yeah, it's actually 0. But how did you figure out 0? Because a lot of people would say 2/3. How did you figure out 0? What you're doing is you're saying, okay, well, first of all, I don't know if you guys see it. Do you see that it's a geometric sequence? I don't know if you see it. In order to get each of the next term, what did I multiply by? Do you see? What did you multiply from 2/3 raised to over 3/2 to 2/4, 3/3, then to get 2/5, 3/4? What did you multiply by? Okay, 2/3. Okay, so guys, you think about if you have some quantity, if you have a pizza or whatever, and you take 2/3 of it, do you see I have a little bit less, right? And then whatever I have, I take 2/3 of that. Do you see I have a little bit less? Okay, and then whatever I have, I take 2/3 of that. And so what's happening here is that you're getting smaller and smaller and smaller and smaller. You're not actually going to 2/3. Your R is 2/3, but you're actually going to 0. Like eventually you'll have a crumb of a pizza. Okay, you're going to take 2/3 of that, and then you'll take 2/3 of that crumb. Okay, and so this goes to 0. So this is saying the sequence. You'd say the sequence here converges to 0. Okay, now what happens if I said the series? Okay, so series is something a little bit different. What if I said, so number 2 is, what does the series converge to? Okay, and so the series would be taking these same numbers, okay, but now not putting commas in between them, actually putting plus signs in between. Okay, actually, I'm sorry, let me go back to this. This was 0 if you did the podium, but remember, you can always do these 2 ways, right? You can do the podium or you can take the limit. Do you remember on the first worksheet, I said, hey, if one's easier than the other, do the other method. Okay, you're gonna get the same answer. So let me just do it algebraically. Go back to sequence, guys. Do it algebraically and see if we can do this algebraically. Yeah. Yeah, yes. But right now, I'm not proving it right now. Yes, yes. The series, if the series converges or diverges, yes. But the sequence still converges to 0. But I can't, at this point, prove if the series converges yet. But I'll show you how I can. All right. This right here, you can take it the limit or you can take the podium. I'm going to take the limit here. Do you see how I split the 2n to 2n times 2 like that? Do you guys see that? Right now, this is a little foreign to you, but we're going to do this a lot, okay, coming up here on one of these tests. So I just want to show you guys that you can split this up. And if you split this up with limits, you can actually move scalars, just like derivatives and just like integrals. You can move scalars to the front, Okay, so this becomes 2 times a limit as n goes to infinity, that's an n, okay, of 2n over 3n. Now I want you guys to think about this 2n over 3n. Any idea what this answer is? As n gets bigger and bigger and bigger and bigger, do you see that this is small over big? Right, this number is always going to be smaller than this number, okay? And this number is going to go to infinity faster, okay? So this is going to be small over big, which is 0. So what you get is 2 times 0, which is 0. And so this is equal to 0. And so do you see you got the same answer, okay, whether you did the podium or the limit? Sometimes one way is easier than the other. Okay, so let me go back to the series. The next question is, does this series converge? Okay, and just because the sequence converged doesn't mean the series converges. If we try to find out if the series converges, then the way we do it is we figure out if its sequence of partial sums converges. Do you remember we talked about that? If the sequence of partial sums converges. Just because the sequence converges does not tell us anything about the series converging. Everybody good with that? Okay, unless you use my tests, all right? So let's just think about this. Right now we have 3 tests, but you actually, will eventually have 10 tests to figure out the answer to this question. Does this series converge? Which is a different question from does this sequence converge? All right, so this is saying, let me go ahead and plug in my numbers. So this is starting, there's a typo here. This should be n equals 1. So this is saying starting with n equals 1, okay, let me put in my series. So this means it's the same numbers that I had before, okay? But what I'm going to do is put plus signs in between instead of commas in between, okay? And my goal now is not to see what the last blank is. My goal now is actually, so this is actually an equal sign here, is actually to tell me what this sum is. And that is what a series converges means. It means tell me what this sum is, okay? Now, how do you figure out what the sum is? One way is kind of like just brute force. But another way is to look at it carefully and say, you know what? I think this is a geometric series. Do you guys see it's a geometric series? And my R is equal to what? 2/3. And is R less than 1? If R is less than 1, do you remember we had a formula we could use, right? For the sum of an infinite geometric series. Okay, now this formula, remember, only worked if this R is less than 1, and this R is less than 1. The absolute value of it had to be less than 1. And my sum was equal to A1 over 1 minus R. Okay, now I'm always telling you guys to be careful. This A1 doesn't mean when n equals 1. Make sure you understand that. This A1 means whatever is in your first blank. It turns out in this situation, it is n equals 1. But had this been n equals 2, it would have been this blank. Does that make sense? It's whatever is in your first blank, which here it's n equals 1. So I'm going to take this number here. Okay, I'm going to put it over 1 minus R. And you get 4/3 over 1/3, which is 4. And so this sum, this, if I added this up to infinity, I would get 4. Does that make sense to you? What is the difference between a sequence converging and a series converging? They're 2 separate things. All right. The other way to find if this, the brute force way to figure out if this sum actually, if this series actually converged or not, is actually to find the sequence of partial sums. So I'd say, the first partial sum is 4 over 3. The second partial sum is 4 over 3 plus 8 over 9. The third partial sum is 4 over 3 plus 8 over 9 plus 16 over 27. The fourth partial sum is 4 over 3 plus 8 over 9 plus 16 over 27 plus 32 over 81. And then what I do is I turn these all into decimals, and who knows what the decimals are, but I would put it into a sequence. Okay, this is taking me a long time. But do you guys see, I would put this into a sequence, S1, S2, S3, S4, and then try to figure out the last blank of this sequence. And that also should be 4. Does that make sense? So this is kind of the brute force way to do it. This is kind of the smart way to do it. But I also need to tell you this. Anytime you're asked if a series converges and what value it converges to, you're actually being asked for a sum. Are you guys good with that? You're actually being asked for a sum. And of all the tests that we do, okay, so please pull your formula sheets out. We're going to make sure everything's filled out on that today. But on your formula sheet, there are going to be 10 different tests that you can use. There are only 2 tests that you can actually figure out the sum. One test, let me see. One test is a geometric series test, and the next test is a telescoping series test. Those are the only 2 tests that I could actually ask you the sum for, okay? If I asked you for a sum, it's going to be one of these 2 tests. Every other test, you can't figure out what the sum is. So it's not going to be a valid question, all right? Okay, guys, so if you pull out your formula sheet, you should have this filled out. So hopefully you have, if you don't have it filled out, fill it out now, okay? We've done the first 3, interim test, geometric, and telescoping. Again, the telescoping is not an AP test, but it is on your test, okay? This column is the conditions for convergence. So for geometric, your R must be less than 1, the absolute value of R. For your divergence test, the nth term test, you never can figure out convergence. So there is never anything here. You can never figure out anything that converges here. Over here, if your limit is not equal to 0, then you do converge. If you look at the sums, you only have a sum here and you have a sum here. If you go look at your whole list on this right side, you never have another sum, okay? So FYI. Okay, so let's go look at some examples here. Things that we should know. If you look at this first problem here, guys, this is what your test is going to look like, okay? You'll have a whole bunch of these series, and I'll just ask you, the directions will be on the top. Tell me if this series converges or diverges. Tell me what test you use. Justify, 3 things. So for each problem, you're going to have to show me those 3 things. So let's go ahead and start with this first one over here, okay? In my mind, on my test, I'll say, is this a geometric series test? That's what I'll say first. Is it a geometric series test? If I put in whatever this is first, if I put in 1, I get -3, I guess. If you put in 2, you get 5 over -1. If you put in 3, you get 6 over 1. Okay, do I multiply by the same number each time to get the next number? No, not a geometric series test. Then I think, okay, is it a telescoping test? Okay, it doesn't even look like a telescoping test, so no. Is it an nth term test for divergence? If I take the limit as n goes to infinity of n plus 3 over 2n minus 5, what do I get? 1/2. Is that not equal to 0? Then therefore, this series diverges by nth term test for divergence. Does everybody see how this works? And this would be my answer. This is what I'm looking for on the test. Guys, this is not like, you know, 5th grade math where I'm looking for an answer, okay? I'm not looking for an answer. I'm looking for, does this series diverge or converge? What test did you use? And show me your justification. I'm looking for all of these things, okay? The answer is not the series diverges, okay? I'm not looking for an answer. I already know the answer, by the way, okay? I'm looking for, can you justify your answer, okay? And that's basically, in the end, that's basically what math is. The truth is, math is actually so easy that mathematicians already know the answer. Nobody's looking for the answers anymore, okay? You're looking for, do you know how to justify your answer? Can you communicate your answer so that you can convince other people of your answer, okay? All right, let's look at this problem here. Is it a geometric series? Is it, do I multiply by the same number to get the next number, to get the next term? Yes, what is that number? Okay, so that is your R. Make sure you understand, that is your R. That is not what your sequence converges to. That is not what your series converges to. It is really just what your ratio is. All right, this is a geometric series test. Your R is less than 1, right? So can you tell me, is this series going to converge or diverge? Converge, okay. By what test? Geometric series test, okay. And then you need to show me your justification. Everything in red here is what you need to have on your test. I guess you don't need the therefore. So everything in red here is what I'm looking for. If you wanted to substitute this for R is less than 1, that would be perfectly fine too. I would accept that also. All right, but you need to show me 3 things. Does the series converge or diverge? What test did you use? And show me your justification. Yeah, Tyler. Only if they ask. Okay, so only if they ask. So if I do ask you what the sum is, which I actually will on your test, you will have to figure out the sum. So that would be the sum is equal to A1 over 1 minus R. This would be, just take this first blank, so that's 3 over 1 minus, is that 1/2? So that would be equal to 6, I believe. You can check me on that, okay? All right, let's look at this problem right here. Which test do you think we're going to use? Telescoping. Okay, just a warning. Telescoping always looks like this, but just because it looks like this doesn't mean it's telescoping. Is everybody good with that? Telescoping always looks like 2 terms or 3 terms added together, but just because it looks like that doesn't mean it's telescoping. So let's go ahead and see if it's telescoping. Plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. Okay, Patrick, are you with us on this? Okay, you have to write all this out. This is your justification. Okay, plug in 6. And of course, this goes on forever. All right, this is a series. So you're going to add all these together. So you'll have plus signs in between all of these. Okay, and I'll be looking to see if you know how to plug in for these telescoping tests. Then what you're doing is you're looking for collapsing. Okay, so for us, our telescoping test will always converge. So these things need to collapse. So do you see the 1/3 collapse, the 1/4 collapse, the 1/5 collapse, 1/6 will collapse, and everything subsequent is going to collapse. Do you agree with that? Everything subsequent is going to collapse. So what do I have left here? Do you guys see it? 3/2. Okay, you actually don't have to tell me 3/2 unless I ask for it. So if I ask for the sum, you'll have to tell me 3/2. I can only ask you for the sum for 2 different tests. Which 2 are they? The geometric and the telescoping. Otherwise, I won't ask you for the sum. And so that means that's actually a big hint. If I ask you for the sum, then I'm actually already telling you that it's a geometric or a telescoping test. That's kind of a big hint too. Okay, so right here, you would say the series converges. The telescoping test for us anyway is always a convergence test, okay, by the telescoping test, telescoping series test. And what's the reason? The justification, I just need to see your work here. I actually don't need to see that it equals 3/2, but I do need to see your work that it collapses, okay? All right, let's look at these last 2 problems, okay? And the same thought process goes through this. You look at this and you say, is it a geometric series? Actually, this is not. You're not going to multiply the same thing to get each term. Is it a telescoping test? No, it doesn't look like a telescoping test, okay? Then I jump right in. The only other test I know is the interim test for divergence. Any idea what this is? Do you guys see that the 3 is negligible, right? What is the square root of n squared? N. So what's n over n? 1, okay? 1 is not equal to 0. Oops, not equal to 0. So therefore, this series is going to diverge by nth term test for divergence. And my justification is right up here. That's my justification. Okay, what about this last problem? Any idea which test will you use for this last problem? Which test is it? It's geometric. Yeah, think about the podium. Plug in 1, plug in 2, plug in 3, plug in 4. Do I multiply the same thing to each number in order to get the next term? Yeah. What's my R equal to, guys? Is it less than 1 or bigger than 1? Okay, so guys, is this series going to converge or diverge? Diverge. By what test? Geometric series test. And there's my justification right there. All right, how are you guys feeling about the first 3 tests that we've done so far? Okay, I know some of you guys need help on, I think it's number, I'm not sure. It's a 1 plus k over n homework question. So let me go back to that because you're going to have that homework question again today. But let me just go ahead and jump into the integral test, and then we'll go back to that one question that you guys have on homework. So what is the integral test? So today we're going to do the integral test and the p-series test. The integral test says that if you have a series and you change that series into an integral, okay, so whatever series you have, change all your n's or your k's into x's. Take the integral and make these your limits, okay? If your integral, then just take the integral. If your integral converges, then your series will converge. If your integral diverges, then your series will diverge, okay? And I always think of that as they walk hand in hand, okay? If your integral diverges, your series will diverge. If your integral converges, your series will converge. So for example, if I take the integral, okay, and I get an answer for it, so let's say I get 1/2, that would mean my integral converged, and that would mean my series converges. Does that make sense? Now here's what students go wrong at. Then they say, oh, that means the sum, if this is equal to 1/2, that means the sum here is equal to 1/2. And that is not true. I mean, it could be true, but it's not necessarily true. If your integral converges, meaning you get a number, whatever that number is, okay, all it means is your series also converges. Does that make sense? This number here is not your sum, okay? You can only find the sum for the geometric series test and the telescoping test. Everybody good with that? Please don't say that this is a sum, but it actually is an important number. This number actually ends up being what we call our lower bound. Okay, so this number here, whatever you get for the integral, is actually your lower bound, meaning that if you were to guess what the sum is definitely, or like the series is, like if you added all of the series numbers together, it is definitely bigger than or equal to 1/2. Is everybody good with that? It's a lower bound, that's all it is. Okay, it could be equal to it, but it's definitely equal or bigger, and that's all you know. Then you can also, for the integral test, form what we call the upper bound, okay? So even though you can't figure out what the sum is, so this is the real sum, you can estimate it with the lower and upper bound if you're doing the integral test. And the upper bound is going to be the same number, whatever it is, 1/2 or whatever it is, plus your first term, okay? And I'll talk about your first term in a second. But this is basically what you need to know about the integral test. The other thing you need to know about the integral test is when you do this integral here, your function here, whatever this function is, it must be 3 things. It must be continuous, it must be positive, and it must be decreasing. If all these things are not true, you cannot use the integral test. Okay, so the integral test only works if these things are true. And I would say usually it's true, but I've seen AP questions say, can you use the integral test, or which one can you use the integral test on? They'll give you 3 different series or 4 different series. And you have to know continuous, positive, and decreasing. And if it's not all 3 of these, then you can't use the integral test. Okay. All right. Let's go ahead and do one. It'll make more sense. Let me see. Oh, okay. I wanted to talk to you guys about this. This actually is the lower bound, a picture of the lower bound and upper bound. You don't have to understand this, but if you do, it'll help you just understand why you have a lower bound and an upper bound. If you think about a series, what it is, it's a sum of a whole bunch of discrete numbers, okay? And so the height of these bars represent the discrete numbers, okay? And since this is just by 1, you know, the area of these bars actually represent the discrete numbers, okay? And so if you took the area under the curve, okay, I don't know if you see it, but this area under the curve, okay, which is like your 1/2 that I said, okay, it's always going to be less. Do you see it? Less than your actual series, okay? And then if you went over here and did the same thing, A1, A2, and you got the series here, if you took the area under the curve and added it with A1, okay, then what you get is an upper bound. This is always going to be bigger than your series, because your series here is A1, A2, A3, A4, A5, okay? A1 plus your 1/2. A1 plus your 1/2, so that's this here. That's why this is an upper bound, because it's always going to be bigger than your series. Okay, so that's where the upper and lower bound come from. If you want to, you can take this into a closet, sit there and think about it for a while. But really, you just need to know this formula. Okay, all right, now let's go ahead and do some integrals. Your first integral looks like this. Okay, your first series. Okay, now I need to tell you, remember, I'm not going to tell you on the test to use the integral test. So you're going to have to look at this and you're going to have to say, is this a geometric series? Okay, is it a geometric series? And then you have to say, okay, that's 1/7, 1/10, 1, 3, 13th. Okay, you have to say, okay, did I multiply by the same thing each time? No, not a geometric series test. Is it a telescoping test? No, it doesn't look like a telescoping test. What if I take the limit as n goes to infinity of 1 over 3n plus 4? Is it an nth term test for divergence? As n gets bigger and bigger and bigger and bigger, what is this equal to? 0. Is that not equal to 0? Well, that's weird. Okay, guys, if you get 0 on an nth term test for divergence, what do? Do another test. Everybody good with that? Nth term test for divergence only works if you don't get 0. If you get 0, you do another test. All right, so not nth term test for divergence. So for now, the only thing I know is the integral test, okay? And what is the integral test? It's basically an improper integral. It's basically turning your function into an integral and solving. And if you get an answer, then the integral converges and the series converges. If you don't get an answer, if you get infinity or D and E, then that means the integral diverges, and so your series also diverges. They walk hand in hand. That's the integral test. All right, so let's do this. I'm going to do u substitution here. So then du dx is going to be equal to 3. So dx is going to be du over 3. I substitute two things. What two things do I substitute? My u and my dx. So this becomes the integral of 1 over u times du over 3. And I'm just going to do the antiderivative first. I'm not going to plug in the limits yet. It'll get too confusing. Then I ask myself the question, do all my x's cancel out? Why, yes, they do. There are no x's. Is this an easy antiderivative or something on my formula sheet? It would be. What can you pull out, though, to make it an easier antiderivative? 1/3. So I'm going to pull that out. Okay, this is on my formula sheet. What is 1 over u du? Okay, so there is a great answer. Okay, it's just the wrong answer. What do you need to do? Put your u back in. Actually, this is absolute value of u. So the absolute value of 3x plus 4. Okay, and I do have limits I need to take care of, so I erase this c. I put in a win bar from 1 to infinity. But remember, guys, if you go to college and take calculus again, which I wouldn't recommend for most of you guys, but if you do, you cannot plug in infinity. Okay, so this is a limit as b goes to infinity. Okay. Then what you're going to do is first you plug in your b, because you take care of the win bar first. So first you plug in your b, then you plug in your 1, then you slap a minus sign in between. Okay, it's still a limit problem. So let me put the limit as b goes to infinity. What will happen here, guys? And what will happen here as b gets bigger and bigger and bigger and bigger? Yeah, this goes to infinity. And actually, this whole thing goes to infinity. You guys good with that? Because when the ln graph, right, this whole thing is going to go to infinity. So what you get here is infinity minus some number, which is basically infinity. So question, does my integral converge or diverge? Okay, so my integral diverges. So therefore, my series, okay, will diverge by integral test. The series diverges by the integral test, okay? I don't know what the sum is, okay? All I know is they go hand in hand. If the integral diverges, the series diverges. What am I looking for on your paper? I'm looking for, tell me if the series diverges or converges. Tell me what test you use. And if you use the integral test, you have to do all of this right. So I'm looking for the proper work. Even if you end up with the right answer, I'm looking for the proper work to support your answer. So if your integral is wrong, then then you won't get full credit. You'll get partial credit. Okay, I forgot to come up here and check these 3 things: continuous, decreasing, and positive. Okay, so let me just, you will have a calculator on this test, but you really actually will not necessarily have a calculator on AP test for a problem like this. Okay, so if you were to graph this, I don't know if you see it. This looks basically like 1 over x. It's just got some, what do you call it? Transformations. Just got some transformations. All right. So it basically looks like this. Okay. But what you know is the bottom cannot equal 0. So that's going to be your vertical asymptote. So if you calculate this, your vertical asymptote is going to be at -4/3. So somewhere right here, you'll have, it'll look more like that, your vertical asymptote. And you're trying to find the area under the curve from 1 to infinity. So I don't know if you see it, but it'll be this area right here. And so your vertical asymptote isn't going to bother this area. Does that make sense? So you will have something that's continuous. It'll be continuous right here. You will have something that's decreasing, and you will have something that is positive. Okay, so you can use the integral test for this function, 1/3x plus 4. The way I remember continuous, positive, and decreasing is I think that this is an integral test, right? It's an integral test. Okay, and so integral looks a lot like interest. So compound integral. Does that make sense? Compound interest. So that's how I think of it. CPD, continuous, positive, and decreasing. Okay, so those are the 3 things you need to memorize for the integral test. All right, ready for another one? Let's look at this one. Okay. So let's go ahead and check CPD, continuous, positive, and decreasing. This thing, if I graphed it, okay, it would look something like this. It actually would, okay, because as n gets bigger and bigger and bigger, this is going to go to 0. I do see that my vertical asymptote will be here at 0, okay, and I'm going from 1 to infinity, so 1 to infinity. So do you see that's not a problem because my asymptote is outside of this area that I want. Also, this function is continuous, yes. It's positive, yes. And it is decreasing, check. Okay, so I'm going to do the integral test. What is the integral test? I convert this to an integral. Don't forget your dx. Change all your n's to x's, and don't forget the dx. This turns out to be an easy antiderivative, so let me just rewrite it. You're going to add 1, divide by -2, so that becomes the integral of -1/2 x to the -2. That's the integral plus Charlie. Okay, -1/2 x to -2 plus Charlie. Yeah. No, there's nothing wrong with that. Yeah. This is just easier to see. All right, so then this is going to be, guys, this is going to be plus c, but my c is going to be replaced with 1 to infinity. All right. And I just want to say, those of you guys who had trouble with the improper integrals test, a lot of it was because you didn't change your negative signs, okay? This negative here, it doesn't make sense to plug into any exponent with a negative, okay? And a lot of you guys, when you solved it, I could tell it didn't make any sense to you, okay? So you really want to change this to -1/2x² from 1 to infinity, okay? Just FYI. Otherwise, you end up getting weird answers, especially when you have to plug in 0. A lot of you guys plugged in 0 and said that the answer was 0. Actually, 0 plugged in here is not actually 0. 0 raised to the -2 is actually 1/0², which is actually in limit land infinity. And so a lot of you said that was 0, and so you got the wrong answer, okay? So always, guys, if you see a negative exponent, change it to a positive exponent using algebra 2 rules. I'm going to cross out these infinities because you can't actually plug in infinities. So what you have is a limit as b goes to infinity of -1/2x² from 1 to b. Okay, what do you do next? First, you plug in your b. Then you plug in your 1. Okay, take it a step at a time. Then you slap a minus sign in between. And this is still a limit problem. Okay, if you have minus, minus, you're going to get a plus here. Okay, now let's do the limit. Guys, as b gets bigger and bigger and bigger, what's going to happen to this first term here? 0. What's my answer going to be? Guys, is 1/2 the answer to this series? No, it is not a sum. So let me emphasize that. That is not a sum. I know you want it to be a sum, but we can only get the sum of the telescoping series and the geometric series. What this is the lower bound, okay? So let me just go ahead and do my conclusion up here. My integral converges. So therefore, my series will converge, okay? It walks hand in hand. It doesn't converge to 1/2 though, okay? But it does converge, and that's going to be by the integral test, Okay, so these are the things I'm looking for. Did you tell me what test? Did you tell me if your series converge or diverge? And show me your work, okay? Then this 1/2 is actually a lower bound. So if I were to try to figure out what this were equal to, what this sum was equal to, even though I can't figure it out, I know that it's bigger than or equal to 1/2. Does that make sense? That's what the 1/2 means. It's a lower bound, okay? The upper bound is going to be A1 plus 1/2. So the key now is just to figure out what the upper bound is. What is this A1? A1 is, go back up here and just do your podium for your first term. Now be careful. It doesn't always mean n equals 1. It's just whatever this is. So if this were n equals 3, your first term would be at n equals 3. Does that make sense, guys? Is that clear? Please don't just always plug in 1. It's just your first term. But here your first term is n equals 1. So plug in 1, I'll get 1. So what that means is this is actually equal to 1 plus 1/2, okay? So if they ask you for your upper bound for an integral test, my upper bound will be 3/2. If they ask me for my lower bound will be 1/2. If I added all the terms of this series together to infinity, I would get some number that's between 1/2 and 3/2. Does that make sense? If your integral diverges, you never have an upper and lower bound, okay? It's only if your integral converges. Okay, you guys comfortable with integral test? Now we're going to go to P series, okay? And what P series is, it basically is a special integral test, okay? So let me move to the P series. Okay, so what P series says is, first guys, I'm just going to help you fill out your P series. So please go to your 4th page. Your 4th page looks something like this. It says a P series test, and you have some blanks, okay? If your P is bigger than 1, your series is going to converge. If your P is between 0 and 1, your series is going to diverge. If your P is equal to 1, your series is going to diverge. So please put these into the blanks, okay? And the P series is basically just something that looks like this. If you have a series that looks like this, okay, what happens is if you took the integral of it, and it doesn't matter what number you start with, but I'll start with 1 here, okay? If you took the integral of it, if this exponent here, so we're talking about this exponent, okay, so all these are talking about your exponent. If your exponent is equal to 1, you're always going to diverge. If your exponent is between 0 and 1, you're always going to diverge. And if your exponent is bigger than 1, you're always going to converge. Okay, so let me give you an example. If you go back to page 3, if my P is equal to 1, I'd have the integral of 1 over n, basically. Okay, 1 over x dx, okay, from 1 to infinity, okay? If I took the integral of that, what I would get is ln of x, okay, from 1 to infinity. But I'm going to replace that with b. So I'm doing this a little bit quickly. But then what I'd do is I'd get rid of the win bar. Okay, so the win bar is b and 1. So I'll get rid of the win bar. If I plug in b goes to infinity, this here will go to infinity, and I'll get infinity. And do you see that my integral would diverge? Okay, so what this is saying that anytime you have something that's 1 over n, and this p is a 1, so here my p is 1, see my exponent is a 1, and you took the integral of it, you're always going to get ln of b, which will always give you something that diverges, okay? If this number is bigger than 1, so let's say this number, this exponent was 2, okay, if it's 2, then what would happen is if you took this integral, what I would get is x to the negative 2 dx, like that. Or actually, didn't we do 3 already? Did we already do 3? Okay, and so we did the 3. If you do that, is that the one we did? We did something. Yeah, we did 3. Okay, what you'll always get, and we got that this one was 1/2. Do you remember that? You got the integral converged. Okay, so what it's saying is that if this number is bigger than 1, your integral is always going to converge. So therefore, your series will always converge. Okay, and if this number is ever less than 1, so let's say we had like that, what would your exponent be there? You see, it's really 1/2. Then, if you did this whole rigmarole here, if you did this, okay, you'd actually get the integral diverged. And you can do it for fun, but you'll get the integral diverges. And if the integral diverges, your series is going to diverge. It's basically the integral test, some special, numbers in the integral test. All right. So let's go ahead and go back to your fourth page, and let's do those problems there on your fourth page. Okay. So on your fourth page, you have this problem right here. Okay. So guys, can you guys see what my p-value would be here? This is 1 over n to the 1/3. Do you see that? So my p-value is 1/3. Is that bigger than 1 or less than 1? Less than 1. Then you would say, therefore, you actually don't have to say therefore. So you can say this series diverges by p-series test. Okay, and your reason would be because p is less than 1. Does that make sense? Okay, so it's easy. Really, it's just an integral test. If you took the integral, your integral would diverge, so therefore your series would diverge. Okay, yeah. You can always use the integral test. Okay, the p-series only works if you have this format, n raised to some power. Does that make sense? So, no, you can't use, you haven't done that test yet. Yeah, so you can't, this -2 keeps you from doing, well, no, you could do the integral test. You'd have to do the integral test. You can't do the p-series. Yeah, so this would be, sorry, this would be the integral test. It's actually another test too, but yes, it's an integral test. Okay. You notice you could also do the integral test on this, right? The p-series is just a shortcut. Okay, so guys, look at this one. What would your p be here? Okay, 5/4. Do you see that's greater than 1? Okay, so you would say my series converges by p-series test. Okay, and what's the reason? This is the reason right here, because p is greater than 1. Do you see how easy that is? Okay, let me give you a little bit more of a hard problem. Okay, what if I said this one right here? Ty, did you have a question?
So like, if it's only test, do we have to write like p equals 5/4 is greater than 1, or do we just like write like series converges by p-series?
So you'd have to have the justification. So I would need this. Yes, I would need it. Okay, what if I gave you this problem right here? And actually, it doesn't have to be n equals 1. So I'll just say n equals 2. Okay, what if I gave you that problem? Yeah, what is your p here? Can you see it? Isn't this really 1 over n, 1 times n to the 1/2? Right? Okay, so when you have the same basis, what do you do with the exponents? You add them. So this is 3/2. So your p here is 3/2, which is greater than 1. Does this series converge or diverge, guys? Converges by p-series test. Okay, is everybody comfortable with that? Another thing I want to add to this, guys, is this. If they put a 2 here, if they put a number here, okay, guys, scalars can move out. Okay, scalars can move out. So guys, if it moves out and you decide that this thing converges, okay, what that means is you get a number. If you multiply it by 2, like let's say this is, I don't know, let's say it's 3. If you multiply 2 by 3, does this series still converge? Yeah, just because you multiply by 2 doesn't change the convergence. Everybody good with that? So anytime they put a scalar, like even for the diverge one, like this one diverges, if they put a 5 here, okay, this thing diverged. You could pull this 5 out. You could pull this 5 out, okay? If this thing diverges and you multiply it by 5, like it's infinity, you multiply it by 5, isn't it still infinity? Does that make sense? So putting a scalar in here doesn't change anything. Everybody good with that? So don't let that mess you up. The other thing that students get confused by is this. So let me do this one. What is the difference between this? Maybe I'll get a clean sheet here. What's the difference between this and this? Which one converges and which one diverges, and which test would I use? This one is a p-series test, right? What's this one? Is this a p-series test? No, it's a geometric test. Very good. Okay, this one is a geometric series test. Okay, what's your r equal to here? 1/3, which is less than 1. So this series would, I think this is less than 1. So this series would converge, right, by geometric series test. What about this one over here? This series would converge by p-series test. Okay, but do you guys see the difference? One, this is not a P series, and this is not a geometric, but they're kind of similar. Okay, so flesh that out in your mind. Okay, if you guys look at number 1 on your homework, what you're gonna have to do on number 1 is actually make it into a formula. Okay, so look at number 1 on your homework. You're gonna have to turn that into a formula. All right, and then figure out how to do the problem. This form is a little bit hard to figure out, so I'm going to help you with it. Does anybody see it, actually, by any chance? What that could be? Number 2 is actually easy to figure out to a formula. This one right here, do you see it's ln of n over n? That one's pretty easy, right? That's the formula. But be careful, you don't start with 1, you start with 2, right? So on this problem, you're going to take the integral from 2 to infinity of ln of x over x dx. Just FYI, that's what you do for that problem. It's going to be a u substitution with u equals to ln of x, okay? This one right here is going to be 1 over n squared plus 1. See if that works out for you guys. This number right here, I think, which is number 4, you're going to have to also figure out the formula for that one, but I think this one's pretty easy.